In this video, we're going to be factorizing algebraic expressions. Now, the important thing to know about this is that factorization is the opposite process of expanding. So instead of removing brackets, we're actually adding brackets in. Now, the key part of factorizing is knowing how to find the highest common factor. So we're going to do an example just looking at that. Now, you may see highest common factor written commonly as HCF. Throughout this example, you'll see that HCF is used instead of the words highest common factor. So this example asks us to determine the highest common factor of the following. So we'll start off with A, makes sense. We've got 8A and 20. Now, we're normally used to dealing with the highest common factor with just numbers. Now we've got letters involved too. In order for a letter to be a high common factor, it needs to actually be just common to both, and in this case A is not. So we know that the highest common factor is just going to be a number, and it's going to be the highest number that we can divide 8 by and by 20. Now it's important to know that we just need to find, just looking at the factors of 8 and see what the highest one that works with 20. So I'm just going to list a few of the ones that work with 8. We've got 1 and 8, and then we've got 2 and 4. Okay, so we'll just get out a calculator and we're just going to work through and see if starting with the highest one, if they work. So 20 divided by 8 gives us 2.5. It's not a whole number, so it's not a factor. We'll go to the next one. It's 4. That gives us a number. It's 5. Now the number itself doesn't matter in this case. All that matters is this, that 4 is the highest common factor that works with both 8A and 20. So our answer for A is just the number 4. Now for B, you'll notice we've got 3x and 6x. So if we look a bit closer, we know that, well, there's an x and there's an x. So x is a common factor already, but we need to know what the highest common factor of 3 is, and 6. So we'll just list the ones for 3 just like we did for 8, just the lower one. So we've got 1 and 3, and that's it, because 3 is a prime number. Those are the only two factors. All prime numbers only have two factors, 1 and itself. Well, technically there's 4. There's going to be 1 in itself in the negative versions, but in just this case we're just going to deal with the positives. So we've got 1 and 3. Now using 6, we'll just see, does 6 work with 3? We got 6 divided by 3 gives us 2. So that's a whole number, so it works. So 3 is the highest common factor for the numbers. We've got an x as well, so 3x is our answer for B. Now for C, we've got 10a squared and 15ab. Now you can see that first of all the common letter is A, because there's 2 a's here and 1 a here, and there's a b but no b. So the common letter is A, or pronumeral is A, and we need to figure out what the highest common factor in regards to the numbers are. So once again, we'll take the lower number. We'll list the factors. We've got 1 and 10. We've got 2 and 5. And that's it. They're all our factors for 10. So let's start with the highest one, see if it works. So we've got 15 divided by 10. It doesn't give us a whole number, so 10 doesn't work. Let's go to the next highest number, which is 5. And that works. So 5 is the highest common factor in regards to the number, and if we look at the letters, it's just, as we said before, it's just A. So 5A is the HCF of these two terms. Okay, now we've got that idea down, we're going to start using it in the form we're actually factorizing an expression. So here we're factorizing just simple expressions, okay? And when we say simple, it just means that it's just the basic idea. It's just a stepping stone to getting all the ideas down. So first of all, we're going to factorize 4x plus 20. Now remember, it's the opposite of expanding, so we're going to be adding some brackets here. Now, once again, we're going to find the highest common factor of 4x and 20. Now, as you do this more, it will become easier as you go. For instance, let's just assume here that 4 is the highest common factor. Let's just test it out before we even get further. We know that 4, it goes into 4 because that is the number itself. 20 divided by 4 does give us a number, and it's 5. That actually matters now. It didn't matter so much before in the other question because we weren't doing anything with the numbers that we were getting. We just needed to make sure it was a whole number. Now it actually matters. So, when we say that 4 is the highest common factor, we're going to remove it from the situation. So here we know that 4 is a common factor, so I'm going to take it out and we're going to have the rest of the stuff in brackets. And what I mean by stuff is what's left over once we take out that 4. So if we have 4x and we take out a 4, we're just going to be left with x. Notice I'm saying take out, not take away. So we're actually dividing. 4x divided by 4 just leaves x. And we know that 20 divided by 4 gives us 5 because we did it before on our calculator. So we're going to have 20 divided by 4 is 5, and it's a positive 5, so that's going to be our answer. I'll just write it again, just a bit neater. So it's 4 outside of x plus 5. Now I said that factorizing is the opposite of expanding. So just to check that we're correct, I'm going to expand this to make sure it all works. So first of all, we're going to do 4 times x, or that's 4x. We've got 4 times positive 5, that's going to be positive 20. And you'll notice that that is the same as that. So this is one of those times where as you do the questions, you'll actually find that you can check as you go without checking any actual answers. You can check it within your own working, assuming everything's correct. So let's do that again for B. So first of all, the highest common factor of 6a and minus 15b. So we know already that there's no letters involved, it's just the numbers. But let's try a couple of things. So we'll start off by, in this case it looks a bit more difficult, so we're going to just list the factors of the lower number, so it's 6. We're going to have 1 and 6 and 2 and 3. So let's check. Does it work for 15 divided by 6? Does that work? No, it doesn't give us a whole number. So let's try the next highest number, which is 3. It gives us 5. Okay, so we can use that. So that means 3 is the highest common factor for this situation. So I'm going to rewrite it with 3 on the outside of some brackets. Now 6a divided by 3. Well, first of all, 6 divided by 3 is 2. So we're going to be left with 2a. And then we've got minus 15b. So minus 15 divided by 3 gives us negative 5. So it's negative 5b. And that's our answer for B. We've done it all in one line. So that's what they mean by simple expressions. You can pretty much do it in one line. Sometimes even if they get harder, you can still do it in one line with good practice. So there we go. Once again, just to double check that we're right, I'm going to expand it. We're going to have 3 times 2a, that is 6a, and 3 times minus 5b, that's negative 15b. So it's the same as the question, so we know we've done it correctly. Now, we're going to be factorizing with common pronumerals. So still, we're factorizing the following. It's still the same type of question, but in this situation, it's more than just the numbers that have a common factor. It's also the letters. So let's look at A here. We've got 8y plus 12xy. So first of all, you can see that there's a y in common, so that's going to be important. But we need to know what the highest common factor of 8 and 12 is. So first of all, I'm going to list the factors of 8. We're going to have 1 and 8 and 2 and 4. And we'll try starting off with the highest number, and we'll see if we get a whole number from that. 12 divided by 8 gives us 1.5. It's not a whole number. So we'll try it again with the next highest number, which is 4, and it works. So that means that we're going to have 4 on the outside of our brackets. And so 8 divided by 4 gives us 2, and that's going to be 2y. And then we've got 12xy, and we're going to do 12 divided by 4, which is 3, so it's positive 3xy. Now, it said before that we're factorising with common pronumerals, and there is a common pronumeral, and I forgot to take it out. Well, that's a-okay. We don't have to worry too much. We don't have to start from the beginning. We can, whenever you notice that you've forgotten to take something out, you can always take it out during your the solving of the question. So I'll just take out those y's now. So we're going to have 4y on the outside, and we're going to just remove, whenever there's a 1y here, we're going to just take it away. So we're going to have 2 plus 3x, and that's our answer there. Now once again, you can test yourself if you want to expand this to show that it works, but following this, it's definitely worked based on answers. So we'll just keep on going. We've got here 4x squared minus 10x. So we'll do the same process once again. List the common factors of the lower number. We've got 1 and 4, and, well, it's 2, because 2 times 2 is 4. And we're going to check, starting off with the highest number, what we can divide 10 by. 10 divided by 4 doesn't work. 10 divided by 2 does. It gives us 5. So 2 is our number, and there's x. There's at least one x that's in common. So when we remove 2x from 4x squared, 4 divided by 2 is 2. And when we divide x squared by x, we're left with 1x. So it's just going to be 2x there. And then here we've got minus 10x. Minus 10 divided by 2 gives us negative 5. And we've already removed the x, so that's our final answer there. Okay, so assuming you notice that there's a common pronumeral, you can take it out at the beginning, and you only have to do it in one line, but if you forget to do it, that's okay, it just takes one extra line. Now, our final example, it says factorising expressions by removing a negative. So whenever there's a negative, you can remove it. You just have to make sure that everything else stays the same. So what I mean by that, it says factorise negative 10x squared minus 18x. First of all, what's a common factor? Well, we know x is going to be 1, but let's just list the factors of 10. We've got 1 and 10 and 2 and 5, and let's see which ones work. So 18 divided by 10 doesn't give us a whole number, so let's try the next highest number, which is 5. Doesn't give us a whole number. The next highest number is 2. 9, so it works, it gives us a whole number. So 2 is our highest common factor in this situation. So the way we can answer this, we'll have 2 on the outside. You notice I left a gap because there's a negative both these. So I'm going to take that out as well. And there's also a common x. So I'm going to take that out as well. So there's lots of things that we're factorizing out of this expression. Now, let's take it through the processes. I'm going to make sure I put in the negatives in the calculator and make sure we're really getting this right. So we've got negative 10 divided by negative 2 gives us 5. Now it's 5 is the number, but we've got x squared divided by x. That's just going to leave us an x. And then we'll do it again for negative 18x. So we've got negative 18 divided by negative 2 gives us positive 9. And x divided by x, they cancel each other out. So that's our final answer. Okay. Now, I'll just show you what it would look like if we didn't take out the negatives. And you can see where it's a little bit different. Okay. So if we don't take out the negatives, we're going to get exactly the same thing. It's going to be 2x on the outside, but then it's going to be negative 10 divided by 2 is negative 5x, and negative 18x divided by 2x is going to be negative 9. So it's the same, but there's just 2 negatives here instead of 2 positives. 2 positives there and 2 negatives. So it's important to try and remove a negative if you can, if it just means that there's going to be more positive stuff inside the brackets. But if you weren't specifically asked to, that is still correct. But if you are asked to remove a negative, that is the way we would want it. The reason why it's important to know both will become clearer as you progress through maths, but at the moment just know that they're both correct.